Hey guys, today we are going to discuss about the project Bird Species Image Classification using Convolutional Neural Networks. The main aim of the project is to develop an innovative solution that utilizes AI, specifically convolutional neural networks, for efficient and accurate classification of bird species based on their images. The project seeks to overcome the challenges of locating and identifying various bird species, especially those that are rare or difficult to predict. Here we have used CNN to teach the computer how to recognize each and every different birds from the pictures. The CNN are like smart filters that can learn from each pattern and features in the images. They can able to understand the each shape, color, texture and the size, making them well suited for taste like telling one bird species from another. By showing the CNN lot of bird species and guiding it to understand important details, it become a skilled bird identifier. In CNN, there are many image classification algorithms used. Some of the important algorithms are EfficientNet, Resnet, Inception V3, PGG16, and DEN. Here we have used the Resnet 50 architecture. It is a 50-layer convolutional neural network which consists of 48 convolutional layers, one max pooling layer, and one average pooling layer. The classification of bird types is accomplished using the CNN model. The ResNet is employed to construct a deep neural network architecture. The innovation of the ResNet lies in the use of residual blocks featuring shortcut connections that facilitate how the information flows during the training. These blocks includes identity block, convolutional block and ResNet block, enabling the model to efficiently learn features from the bird's images. Now we can move on to the implementation. Here we are importing the dataset from the Google Drive. The dataset which we have taken it consists of 224 cross 224 color images in the JPEG format. The dataset includes a train set, test set and a validation set. Each set contains 201 subdirectories, one for each bird species. By implementing this code, we can able to unzip the folder from the drive and we can able to get all the images. Similarly, we can in this cell we are importing the necessary packages which are used for the execution. First, the TensorFlow. By importing the backend module from the Keras library, which is a high-level neural network API written in Python and capable of running on the top of TensorFlow. Next, the ResNet 50. By importing the ResNet 50 from TensorFlow.keras applications, you can gain access to pre-trained instance of ResNet model. And the layers of convolutional layer, max pooling layer are also imported. The optimizer which we use is Adam optimizer. And in the image generator, it allows you to perform a real-time data augmentation on the fly, meaning that during the training of the neural network, the input images are dynamically transformed into various waves, introducing the diversity into training data and potentially improving the model's generation. Next, the model checkpoint callback is used to save the model's weight during training. This is helpful to capture the best model achieved during a training or to save the model at specified intervals. Next, the reduce LR on plateau callback is used to adjust the learning rate during training. It reduces the learning rate when a certain metric has stopped improving, typically the validation loss. And the early stopping callback is used to stop training when a monitored metric has stopped improving. It helps prevent overfitting by ending training once the model's performance on a validation set starts to degrade. The listDR function returns both files and directories present in the specified path. And the basic pandas are imported, which is a powerful and a widely used data manipulation and library for Python. It provides data structures like data frames and series, as well functions for reading, writing, and manipulating the unstructured data. And the max pooling 2D layer is used to downsample the input along with spatial dimensions by taking the maximum value over an input window. Then flattened layer is typically used in convolutional neural network or other architectures where the input data has a multi-dimensional shape and needs to be flattened before passing it to a fully connected layer. And the fully connected layer in the keras, which and the dense layer is one of the most fundamental and commonly used layers in neural networks. Each neuron in a dense layer is connected to every neuron in the previous layer. In the next cell, with the help of image data generator, we are rescaling the input images. Rescale. This parameter is used to normalize the pixel values of the images. Shear range. Shear transformation distorts the shape of the object. Zoom range. This parameter specifies the range for random zooming. Horizontal flip. This parameter enables random horizontal flipping of the images. And similarly for the test dataset. By using the flow from directory, we have got the training and testing dataset. We have found 20,098 images for training dataset and 1005 images for testing dataset. Here comes the identity block, which is a building block for the Resnet architecture. It is a type of a deep neural network architecture that introduces skip connections or shortcut connections to overcome the vanishing gradient problem during training. First, we are defining the two base classes. And F1, F2, F3 are the number of filters which we are going to use for the convolutional layers in the identity block. The X shortcut is used to save the input tensor. This tensor will be added back to the main path later. The three convolution blocks 2A, 2B, 2C are implemented with batch normalization and ReLU activation function. The shortcut connection is added to the main path using the add layer. At last, the result is passed through a final ReLU activation function. So, the identity block architecture allows the information to flow directly through the shortcut connection without any additional operations. Next, the convolution block, which is similar to identity block. Here, con namebase and bn namebase are strings used to define the names of the convolution and batch normalization layers. These names include the stage and block information to help with the layer naming and organization. As similar to the identity block, we can see the filters and shortcut connections. And finally, we are adding the result through the ReLU activation function. This convolutional block is used in Resnet architecture to capture complex patterns and facilitate the learning of deep neural networks while maintaining the ability to train effectively. The use of the shortcut connection helps mitigate the vanishing gradient problem and allows for training of very deep networks. And at last, the Resnet 50 block. In this block, we first define the input shape for the images, and then the input is passed to the zero padding layer. The layer pads the input tensor with zeros to handle the border effects. And at the stage 1, it includes a convolutional layer, batch normalization, ReLU activation, and the max pooling. After that, from stage 2 to stage 5, each stage consists of convolutional block and the identity block. The number of blocks and the configuration of filters in each block vary across stages, so the input is passed through all these stages to attain efficient training. After crossing all the 5 stages, then the input is passed to the average pooling layer to reduce the spatial dimensions of the input. Then at the output layer, it consists of flattening layer followed by a dense layer with a softmax. The Resnet 50 model is saved in the variable name model, and the input shape is given as 224 x 224, and the 3 is used to recognize the image as color image, and the classes are defined as 201. In the next cell, we are compiling the model with an optimizer of Adam optimizer, and the loss function is categorical cross entropy, and the metrics we have used is accuracy. Here we have used the categorical cross entropy to interpret, and it provides a measure of difference between the predicted probability and the true probability distribution of the classes. And the model checkpoint is used to save the accuracy which we have obtained at each level. And we have defined the number of epochs as 40 and the batch size as 64. Then we are fitting the model with the training set and the test set. We can see that the epochs is completed till 40, and at the last epoch we get an accuracy of 94.25. Next we are plotting the graph between training and validation values. And at next we are evaluating the model which we have trained. The model achieves the test accuracy as 77.51% and the train accuracy as 93.99%. Now to check the model, we are giving an input image with a size of 224 cross 224 and we are scaling it. Then we are passing the image to the prediction function. With the help of the argmax, we get the predicted species. The model predicts it as a 31. The 31 is the number of the species in the dataset. So we can identify that the bird is the 31st species in the dataset which we have given. Thus, we have successfully completed our project Bird Species Image Classification using convolutional neural networks.